Okay, class. I told you last time that we will be talking about different aspects of probability in the next video lesson. But before that, I told you that the fundamental counting principle, which is the previous lesson, will play a vital role in the discussion of the next lesson on probability. So before we get there, let us review on how to apply the fundamental counting principle. Number one, if a padlock has or require four characters to be its password, with each character having a choice from 0 to 9, how many ways can we enter the password? If you said 10,000, then you are absolutely correct. Because again, if you can still remember, what we need to ask ourselves first is how many events are there? And the events here will be the characters, so there will be four. And each character will have 10 choices from 0 to 9 because 0 is included. So if we multiply the number of outcomes of the first event by the second event, by the third event, by the fourth event, we will have 10 times 10 times 10 times 10, which is equal to 10,000. Okay, very good if you got that. Now let's have number two. Answering 5 questions with each question having 4 choices. If you answered 1024, then you are correct. Because again, there are 5 events since there are 5 questions. And then each event has 4 possible outcomes because there are 4 choices. So 4 times 4 times 4 times 4 times 4 equals 1024. Number 3. Choosing the top 3 students from a class of 30. Okay, by the way, I failed to mention that this is without a tie. And that is understandable because when we are choosing top 3 students, it's normally just one student per rank. If you answered 24,360, then you got it right. Why? Because for the top 1 student, there are 30 slots or 30 students to choose from. And so top 2 students, we have 29 students to choose from because one has already been chosen to be the top one. And for top 3, we have 28 students to choose from. So 30 times 29 times 28 is 24,360. Now, the reason why I had you review that because it will play a vital role in solving for probability of simple events. Now, why is it so important? Because remember that we are actually computing for the sample space or the number of outcomes. And if we are going to calculate the probability, it is very important that we know how many outcomes there can be in the sample space. Now, I use this particular presentation for my demo. So there are some activities here that I'll be going through as well, but just quickly with you since this is just a video lesson. Okay, so I would have you say that something is impossible, less likely, meaning there's a little chance of it happening, more likely, or certain. So I don't want you to do the sign language anymore since I'm not seeing you anyway. So you can just think of how likely the ones that I'm going to show you are to happen. Is it impossible, less likely, more likely, or certain? Number one, it will rain today. Okay. When I had my demo, most students said maybe because even though it's hot, there's a chance of it happening, but just less likely. Number two, a living human's heart will beat. Although not all of them said it's certain, most of them said it's certain because, of course, if we are living, our heart continues to beat. Number three, you will not blink for a whole day. Most of them, of course, said it's impossible because um, it is an involuntary movement. So we humans keep on blinking many times within the day if we are alive. The only time that we will no longer blink is if we are no longer physically alive. Number four, you will win the lottery. Okay, on this one, most students said maybe, and the other half said um, it's impossible. Of course, that's understandable because for some, if they are betting, then it's possible for them, or it's more likely, or it's less likely for some. And for others, it's impossible because they are not betting at all. Number five, your crush will be your girlfriend or boyfriend. Now, on this one, they smiled, but most of them said it's impossible because some of them are, of course, awake to reality that this is just in the Wattpad and in movies or in telenovelas that this happens. But some of them said maybe, and some even said certain because they are positive that this will happen. But I don't want to burst their bubble if they think that. Okay, now, why am I asking you to think for the likelihood of something to happen? Because I want you to get the idea behind probability. Because that chance of something happening or its likelihood is what we call probability in mathematics. Probability simply means possibility. It is a branch of mathematics that deals with the occurrence of a random event. The value is expressed from 0 to 1. Probability has been introduced to math to predict how likely events are to happen. The formula for the probability of an event is given by the probability of event A is equal to favorable event over a number of possible outcomes. Don't worry about this letter A here. It can be represented by other letters or even words or even phrases. I just used event A just to give you a general look on what the formula is. But that is just a representation of what event we are talking about. Now, what is a simple event? Since the title of this is probability of simple events. Now, a simple event is one that can only happen in one way. In other words, it has a single outcome. Meaning, if we are just talking about getting an even number, then it's just getting an even number. If you're just talking about getting a 5, then it's just getting a 5. There's no or end. Um, but let us just be very clear. It doesn't mean that we are just talking about one number all the time. We can talk about a group of numbers, but just one category, like all even numbers, or all odd numbers, all prime numbers, or all blue balls, or all yellow balls, but just one. Not like getting ahead and getting a 5 in a die. Those are two separate events. So if you combine them, that's no longer a simple event. That's going to be a different kind of event which you will be talking about in other grade levels. Okay. So now I want you to give the probability of the following events. Number one, what is the probability that at least one head is obtained after throwing a coin 3 times? Now, the key here is to logically think or critically think how many are the favorable events. Again, favorable events are the outcomes in which we are meeting the category. And the category here is getting at least one head. So, meaning, kahit isang head lang, okay na yon. So, the sample space, if we use systematic listing, will include 3 heads, 2 heads, and 1 tail. Head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. And if you count that, that will be 8 outcomes. Now, How will you get 8 without having to systematically list and count? That's where fundamental counting principle comes in. There are 3 throws, and each throw has 2 possibilities, getting a head or getting a tail. So 2 times 2 times 2 equals 8. Now, the condition is getting at least one head. So the favorable events are those in which we can see an H, at least one H. So it can exceed 1 but cannot be less than 1. So we have 1, 2, 3, 4, 5, 6, 7 with H. So we have 7 favorable events. And we just have to put this in ratio or in fraction with the favorable event as the numerator and the sample space or the total number of outcomes as the denominator. And if we do that, the probability of getting at least one head is equal to 7 over 8. And since this can no longer be simplified, this is already our answer. Let's have another example. What is the probability of drawing an ace from a deck of cards? Now, a standard deck of cards may not be familiar to some, so let me just discuss it for a short while. A standard deck of cards is consists of 52 cards, in which it is divided into 4 categories, namely spade, club, heart, and diamond. And each of those 4 categories have 13 cards, including an ace, number cards from 2 to 10, a jack, a queen, and a king. Now, with that said, if we have um, ace, 2 to 10, and jack, queen, king in all 4 categories, that also means that we have 4 aces. Ace of heart, ace of diamond, ace of club, and ace of spade. So we have 4 favorable events. And as I've said, the sample space is 52 because we have 52 cards. And if we put that in fraction form, the probability of getting an ace card is 4 out of 52, which when simplified will give us 1 over 13. Let's have another example. What is the probability of getting a sum of 7 when 2 dice are thrown? Again, you will recognize that you will need to use fundamental counting principle if, for example, we have something like this, 2 dice, and each die, of course, have 6 faces. So, we have to multiply 6 times 6 for the sample space. Okay, I am giving that ahead of time so you will know when to use the fundamental counting principle. So again, if we use the fundamental counting principle, we have 6 times 6 equals 36. And for the favorable events, we can list all pairs of numbers in the die or in each die that will give us a sum of 7. We have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, then 6 and 1. If we count all those combinations, we have 6. And if we put this in fraction form, we have 6 out of 36, which when simplified is 1/6. So the probability of getting a sum of 7 is equal to 1/6. Now, let's have some more questions. What is the probability of drawing a space from a deck of cards? Again, each category has 13 cards, so that goes with spades also. So we have 13 out of 52, which when simplified is 1/4. So we have the probability of uh, drawing a spade, which is 1/4. What is the probability of getting a prime number by rolling a die? So again, a die is just one piece of die. Because if it's plural, it should say dice. Now, what are the prime numbers in the die? Prime numbers are numbers that have only 2 factors, namely itself and 1. So that includes 2 because you can only have 2 by multiplying 2 and 1. 3 because you can only have 3 by multiplying 3 and 1. And 5 because you can only have 5 by multiplying 5 and 1. And if there are three prime numbers from 1 to 6, and there are six possible outcomes in a die, so we have 3 over 6, which is 1 half when simplified. Now let's have, what is the chance of drawing a blue ball from a bowl which has 5 blue, 2 red, and 3 yellow balls? So this is very direct. We have 5 blue balls, so that will be our favorable outcomes. And we have 10 balls because if you add them, we have 10 balls. Now you might think, sir, why did you just add it and not like other times when you multiplied the possible outcomes? That's because each ball only has one color. So you don't have to multiply them. Unlike in dice where we have six six outcomes for each die, or coins which have two outcomes for each coin. These balls only has one color each, so you don't need to multiply them. Okay, they only just count as one for each ball. So we have 5 over 10 because there are 10 balls equals 1 half when simplified. Let's have other questions. What is the probability of drawing a 2 from a deck of cards? Again, there are 4 categories and each of them has 2. So we have 4 twos. So 4 out of 52 equals 1 over 3. Next, what is the probability of getting an odd number by rolling a die? There are 3 odd numbers in a die, namely 1, 3, and 5. So if there are 3, we have 3 over 6, which is equal to 1 half. Number 6, what is the chance of drawing a yellow ball from a bowl which has 5 blue, 7 red, and 2 yellow balls? Again, this is straightforward. We have 2 yellow balls, and there are 5 plus 7 is 12 plus 2, 14. 14 balls in total. So 2 over 14, when simplified, will give us 1 over 7. Now let's have a more complicated one because it will use the fundamental counting principle. What is the probability of getting a sum of 5 by throwing 2 dice? Okay, we have the favorable events including 1 and 4, 2 and 3, 3 and 2, and 1. So there are 4 in total. And since there are 2 dice, we have to multiply 6 by 6, which will yield 36. And if we put that in fraction form, favorable events over sample space, we have 4 over 36. And 4 is equivalent to 4 times 1, whereas 36 is equivalent to 4 times 9. So if we cancel 4, since it's common to both the numerator and the denominator, we will be left with 1/9 as the simplest form. Now, why is it so important for us to know about probability in real life? In real life, we actually have certain professions that use probability a lot. For example, businessmen are calculating the probability of bankruptcy and the probability of getting a profit or getting more interest, so they will not go bankrupt. And engineers are taking consideration the probability of an earthquake, a landslide, uh, the probability of getting improved in that certain area. So it plays vital roles in making good decisions. Also, statistics show that 95% of women who suffer violence suffered it from their partner who drink alcohol. So I'm not stereotyping. There are people who drink alcohol, but they do not harm their spouse. And there are also people who do not drink alcohol and yet they violate their spouses. But just mathematically speaking or statistically speaking, The probability of a woman being violated by her husband is very high um, among spouses with a drunkard husband, meaning women who are known to have suffered violence from their spouses are 95% from women who have drunkard husbands. Only 5% of the women who suffer violence are women with non-drinking husbands. So, although we are not stereotyping, we should also take into consideration the chance of it happening in the future, since you women are going to choose your husbands in the future. So, choose wisely. Do not go with just the mentality of basta pogi. Now, let's have the next one. If a weather report tells us that there's a 0% chance of rain, then it is wise to schedule an important event on that day, even outside. Because, for example, if you have a celebration of your birthday and it's more likely to rain, then just do it inside or indoors. So you will not waste your preparations, your spendings, if it will be ruined by rain. But if there's a 0% chance or very little chance of rain, then you can just go outside as you like, because the chances of it being ruined by the weather is very little or sometimes even impossible. Now, you can also think of other things where we can use probability. Now, I want you to remember the terminologies that I used in the beginning of this video lesson and fill in the blanks. A simple event is an event that has a blank outcome. What's the missing word? If you said single, then you are absolutely correct. Number two, probability means blank. If you said possibility, then you are right. It's a branch of mathematics that deals with the occurrence of a random event. The value is expressed from 0 to blank. What's the missing word? It is actually 1. 0 being the impossible and 1 being the number to represent certainty. Probability has been introduced in math to predict how likely events are to happen. The formula for the probability of an event is given by P of A equals blank over number of possible outcomes. What's the missing word or phrase? The answer is favorable events. Okay, so if you got those words correctly, then at least you have the principles behind what we are talking about. Now, for the application. Again, I use this for my demo. So there are some extreme activities that we apply that we no longer do in usual classes. So I use the Pokemon as my theme, which is probability version. In this particular group work, uh, Aristotle or grade 8 Aristotle um, arranged groups, and each group drew Pokemon cards whose power is the probability of the events in the cards. So we did not use the power of the Pokemon in the card, but we used the um, answer to the probability questions themselves. They will damage all other groups with the answer on their game cards only if they will be able to give the right probability. Meaning, it's not just because you got someone whose probability is very high, then you will win. Okay? You have to answer or give the right probability first before you can use that uh, points. So that's how we did it. And the group who reduces the life of other groups from 1 to 0 wins. Okay, I'm just explaining this to you so you will have an idea how we did it in the classroom setup. So you will know how to behave in actual demo in the future. Now, We use these Pokemon cards, which they have physically with their groups, right? So what I will do, since this is a video lesson, I will read this, and I will just show you what happens if the group will be able to answer correctly. So what is the probability of getting a number higher than 4 in a die? So again, the numbers higher than 4 in a die are 5 and 6. So there are only 2. And since there are 6 numbers in a die, so the answer is 2 over 6, or simply 1/3. So if the group will be able to answer, they will see their Pokemon attacking. Next, what is the probability of rolling an even prime number in a die? So the only even prime number is 2. Not only in a die, but just in general, the only even prime number is 2. So there's only 1 out of 6 numbers in a die, so 1 over 6 is the answer. And they will be able to answer, they will see it. Next, raffle tickets are numbered from 1 to 40. What is the probability of picking a number ending with 0? Okay, so there are only 4 numbers ending with 0 from 1 to 40, namely 10, 20, 30, and 40. So if we put 4 over 40, that is 1/10 when simplified. Next, raffle tickets are numbered from 1 to 40. What is the probability of picking a multiple of 5? Of course, to get the number of multiples of 5 from 1 to 40, you just have to divide 40 by 5. So 40 divided by 5 is 8. So there will be 8 out of the 40 numbers. 8 over 40, when simplified, will give us 1 over 5. So 1 over 5 is the answer to this one. Next, what is the probability of selecting a heart from a deck? So there are 13 heart cards in a deck. So if we just put that in fraction form, 13 out of the 52 cards in the standard deck will give us 1/4 when simplified. For those who are still having a hard time with simplifying fractions, you just have to find the GCF, or the greatest common factor, of the numerator and the denominator, which in this case will be 13. So dividing both the numerator and the denominator by the same number, 13 divided by 13 is 1, 52 divided by 13 is 4. So if they were able to answer correctly, this is what they will see. Next, what is the probability of selecting an even red card from a deck? So the even red card, by the way, this is very tricky because I myself thought that Jack, Queen, King are numbered 11, 12, 13, but it's not. Okay, they are not considered number cards. So the only numbered cards in a standard deck are 2 to 10. So in that case, there are only 2, 4, 6, 8, and 10 for the heart, and 2, 4, 6, 8, 10 for the diamond. Those are the red cards. So there's only a total of 10 cards that are red in a standard deck. So that will mean that we have 10 over 52, which are both divisible by 2. So if we divide 10 by 2, we get 5. And if we divide 52 by 2, we get 26. So 5 over 26 is the answer. And if they got it correctly, their Pokemon. Next, passwords you can enter from 000 to 100 if a padlock requires 3 characters with 0 to 9 each. Okay, this requires the fundamental counting principle. So if we were given a hint that the choices is only between 0 to 100, there are 101 favorable events. 100 plus the 0, which is one probability, oh sorry, one outcome. So 101 outcomes out of uh, 10 times 10 times 10 is 1000. Again, that's the application of the fundamental counting principle. And since this can no longer be simplified, this is already the answer. 101 over 1000. Next, getting a sum of 7 when two dice are thrown. Again, we already encountered this in the examples. We have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. So there are 6 possibilities or 6 favorable outcomes. So we will have 6 out of 36 because there are 2 dice that were thrown. So 6 times 6 is 36. And if we simplify this, we will end up with 1 over 6 as our probability. Next, a class has 18 boys and 9 girls. What is the probability that a randomly selected student is a girl? Okay, so this is very straightforward since it was told that there are 9 girls. So there are 9 favorable outcomes, and the total number of students is 27. Okay, don't mistake it with 18 because the 18 are just boys. So if we add the total number of students, there should be 27. So 9 over 27 is 1/3. So if they answered 1/3. Next, the class has 40 students. What is the probability that a randomly selected student is a boy if there are 22 girls in the class? So this is kind of tricky because what was given are girls. And we are being asked for the probability of getting a boy. So we have to be keen on observing that. So if there are 22 girls among 40, there are only 18 boys. So 18 over 40 is our simplified form. And they are both divisible by 2. So 18 divided by 2 is 9, whereas 40 divided by 2 is 20. So 9 over 20 is our answer. Next, a bag contains 5 quarters, 2 dimes, and 4 pennies. What is the probability of picking a quarter? Okay, so there are 5 quarters, so that will be our favorable events. And there are 11 items in total if you add them. So since we have 5 over 11 and that can no longer be simplified, that will be our answer already. Next, a bag contains 5 quarters, 2 dimes, and 4 pennies. What is the probability of picking a penny? So there are 4 pennies out of how many items? 5 plus 2 is 7 plus 4 is 11. So 4 over 11, which can no longer be simplified, is our answer. Next, a bag has 3 red marbles, 2 blue, and 4 yellow. What's the theoretical probability of pulling a red? So this is straightforward. We have 3 red, and there are how many items or marbles in particular? 3 plus 2 plus 4 is 9. So 3/9, which is 1/3 when simplified. Next, if you pick from the following M&M colors, what is the probability that you choose blue? 5 green, 6 yellow, 8 blue, 7 brown. Okay, so we are being asked for the probability of choosing a blue, so we put 8 as our favorable outcomes. And if we add them, we will know how many total number of outcomes there are. 5 plus 6, 11, plus 8 is 19, plus 7 is 26. Sorry, I should have written 26. Now, both the numerator and the denominator are divisible by 2. So 8 divided by 2 is 4. And 26 divided by 2 is 13. So 4 over 13 is our answer. Next, what's the probability of getting a number greater than 2 when you roll a die? Okay, so the numbers greater than 2 include 3, 4, 5, and 6. So there are 4 in total. And there are 6 numbers in a die. So 4 over 6 is 2/3 when simplified. Next, what is the probability of getting a black card in a deck of cards? Now, there are only 2 colors in a standard deck of cards, black and red. And they are both equal to half of the deck. So there are actually 26 black cards and the number of outcomes is 52, which is 1/2 when simplified. Next, what is the probability of getting higher than 5 in a deck of cards? So, again, the number of cards are numbered from ace to 2 to 10, then Jack, Queen, King. And Jack, Queen, King are all considered higher than 10, although they are not numbered. So, the number of cards higher than 5 include 6, 7, 8, 9, and 10. Then the Jack, Queen, and King. So there are 8. So 32, since there are 4 categories over 52. And they are both divisible by 2. So if we simplify this, this will be, well, actually they are both divisible by 4. So if we simplify this will be 8, and this will be 13. So 8 over 13. However, there are games in which the Jack, Queen, King are not considered higher than 10. So if we were given that specific condition, we only have 6, 7, 8, 9, 10 as the ones higher than 5. So there will only be 20 in total over 52. So 20 over 52, they are both divisible by 4 again. So this will only be 5 over 13. So I would have considered both answers here because it's not specific what game we are considering. Next, what's the probability of getting lower than 10 in a deck of cards? So the numbers lower than 10, if we count A's as 1, are 9. So 1 to 9. And there are 4 categories, so 4 nines is 36. So 36 over 52. Both are divisible by 4. So it will become 9 over 13 if we divide both the numerator and the denominator by 4. Next, what is the probability of getting at least one tail when you threw two coins together? Okay, favorable events because we have head head, head tail, tail head, and tail tail. So there are three possibilities. And 2 times 2 is 4. So 3/4 is the answer because that can no longer be simplified. Now, for your quiz, again, this is supposed to be a quiz, but since this is only applicable to the video lesson given the time, this will only be an assignment to you, which will also be checked on the actual day that I collect your notebooks. Okay, here are the questions. What is the probability of drawing a face card from a deck of cards? What is the probability of getting an even number by rolling a die? And what is the chance of drawing a blue ball from a ball which has 3 blue, 3 red, and 3 yellow balls? Okay, so that will be all for this video lesson, and I will be waiting for your assignment on your notebook. Thank you very much.